What we're going to be doing today is looking at how molecules form the shapes they form. And so what we're dealing with is something called VSEPR. PR. Okay. And that stands for valence, shell, electron, pair, repulsion. To understand what's going on, you need to recall that the maximum number of electrons you can put in an orbital is 2. Pair. Maximum number of electrons in an orbital. And we did orbital notation, for example, with oxygen. We could only put a maximum of 2 electrons in an orbital. So there's 2 more places that oxygen can gain electrons. Remember, this is just a way of keeping up with the number of electrons. It's a way of organizing it so you can kind of keep up with how many electrons are in an orbital, how they can be moved from one place to another, and so are electron dots. Now if we take it from this stage and go to where we hybridize that oxygen, 1s doesn't change because it's not the valence level. The valence level is whatever the highest energy level is for that atom. So the second primary level is the valence level of oxygen. That's oxygen's valence. Okay? So when we hybridize oxygen into Sp3, we're going to do an Sp3 hybridization. Then all the orbitals, instead of having a separate S and P sublevels, we're going to have one kind of new hybridized sublevel called an Sp3. So we're in the second level, Sp3, and the 4 orbitals all kind of go together. So if I combine oxygen with hydrogen, hydrogen only has 1 electron. Only needs 1 more. Okay? So if I take this orbital right here and plug it in with this, so they're going to be the same orbital, then oxygen has gotten 1 more of the electrons it wants, and hydrogen's gotten all the electrons it wants. Then if I take another hydrogen and do the same thing, I share this orbital and this orbital become 1. Okay? They become the same orbital. They're sharing the orbital. Then I've got 2 electrons in the hydrogen, and since I've already put an extra electron here, I've got another electron here now, and now I have 8 electrons in the valence level of oxygen. Okay? So being able to physically do that becomes a little more complex when we're using orbital notation. That's why we use electron dots, or Lewis dot formula. So oxygen, we have 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6 electrons in the valence level, so we put 6 dots around it. Hydrogen only has 1 electron. We only need 1 dot, and I have 2 hydrogens here. And what we're going to do is share those electrons in a single orbital. When you share an orbital and form a single orbital between two atoms, we call that a covalent bond. That's the valence energy level, the highest energy level for that atom. Covalent meaning two valence. Okay? We're sharing electrons in the valence energy level of that atom. What now? That's why we call it covalent. We call that a covalent, actually I should say covalent bond. Doesn't look like coal to you?
Looks like can without
Happy now? Okay. So then, we're going to show that as hydrogen sharing in this manner. The two electrons that are put between the two atoms are shared electrons, and the electrons that are not shared are sitting out here like this. Okay?
So that the one after the arrow is the one where you already put the electrons?
Yes, so this is the Lewis dot formula. Okay? Lewis dot formula. This is called, we just call this simply the sharing arrangement. You might need to know what it is. Okay? So we got a sharing arrangement, then that becomes a Lewis dot formula. And we went through the process of showing you how you get a three-dimensional shape yesterday. Looking at how hybridized orbitals like to avoid each other as much as they can. They still have to be attached to the oxygen, but they want to be as far apart as they can from each other. And when you do that whole process, starting with having the oxygen atom with the electrons equally spaced around that central atom in this tetrahedral drawing. So you go from Lewis dot formula to that. And from that, then you go to the modified, that's called the electron pair shape. You go from that to the modified electron pair shape where we put two hydrogens on there.
So we basically went kind of backwards.
What now?
Like from in the notes. Did you show us what was after the Lewis dot formula yesterday?
Well, this is the order that you kind of figured all out. Is that what you mean?
I still don't know what those things are.
Well, hopefully after making balloon models today, it'll make more sense. All right? And then the last stage is to take those, redraw the same drawing, and take off the lone pairs. And if you do that as I've taught you to do it, you will get a bent molecular shape. Okay?
What is those dots sometimes in the circle? Okay, can you just stop right
Mm-hmm.
Huh?
Dots outside the circle.
What is that triangle with the dots around?
That's a bond that is coming out toward you. Yep. No, this is all get review from yesterday. That's why I put recall here. We're talking about what we did all so far, building up to this point. Okay?